Hello, so today we are going to do this problem, numbers with the same consecutive differences, which is part of Leetcode September daily challenge. So the problem says we get an integer n, and we want to return all strictly positive integers, such that the absolute difference between the digits in that number, the consecutive digits in that number is k, is exactly k. And the other constraint we have is that every number that we return must not have leading zeros, right? So for example, 0, 1 is not valid. And we can return the numbers in any order, right? So if you take a look at the first example, we have n equal to 3, so we want numbers of size 3. And the difference between the digits has to be 7. So we can do 1, 8, 1, because the difference between 1 and 8 is 7. And so it's the absolute value. And between 8 and 1 is 7 as well. Between 2 and 9, 7. 2 and 9, 7. And same thing here and here and here, right? And these are the only possible numbers of length 3, where every consecutive 2 digits will have difference of 7, right? And this one has the consecutive digits with difference 7, but it has a leading 0, so we don't add it, right? Yeah, so that's the idea. Now let's see how we can solve it. Okay, so how can we solve this? Well, the easiest way to think about it is, let's just try all numbers, and as long as the number is valid, right? As long as the portion of the number is valid that we have so far, which is basically that for every 2 consecutive digits, so di, the absolute difference between every 2 consecutive digits, let's say di plus 1, and di has to be equal to k. As long as we have this, we continue adding, and as long as like the length of the number, so let's say it's the number so far, so this would be in so far, is less than n, we can continue, but once we reach n, we need to add that number, right? And also, like, if you look at the constraint here, it's at most 9 for n and k. So if we do a recursion where we explore all the paths, as long as they are valid, we should be fine, right? We should be able to, we should fit in the time complexity. So the first thing we need to do is have a function that is going to explore all the paths for us. So let's call it maybe a helper function, right? And what do we need to have? We need to have the number we have so far. We definitely want to have the length so that we can compare it against n here. We can also just take the length of so far, right? But I'll just have a length variable. The other thing we need is we want to know the last number so that we can compare against it. So for example, 181. So once we have just the number so far here, when we are exploring 1, we need to know what's the previous number so that we can do the difference and check if it's equal to k. So for every I, we want to know I minus 1. And so let's just have it here be last. And our base case is if the length is equal to n, which means we are done. So if the length is equal to n, the other condition that we have is that it must not have a leading 0. So we need to check for that. How do we check? We just check that the first position in so far is different than 0, right? If it is, then we should add the number. And so we need some place to add the numbers, right? So that we return it at the end. And so let's have that variable self.res, and then we can append the number, but we need to convert it to an integer because it's a string. Okay, and now after that, what should we do? So now we need to recurse and do some sort of backtracking. With 1, 8, right, or let's say 2, 9, let's say maybe when we are at 2. We need to just check all numbers, check all the digits from 0 to 9, and see if any of them would fit this condition, right? And so to do that, we can just do j in the range of 0 to 9, and for Python, we need to do up to 10 to end at 9 here. And now we need to check this condition, right? So if the absolute value of j minus the last value, right? So this would be the previous one, and this is the current one. that we are trying, if that's equal to k, then this is a valid, so far is valid, right? So far plus j is valid, right? And so we can call our helper function on that. So far plus j, but we need to convert j to a string so we can add it to this string. And what's the last value now for the next call? Now it's j, right? So let's say we called the function with just so far equal to 2, and so last was equal to 2 as well. And now we go through the loop, and then all of them this is false, and then when we reach 9 it's true, right? So we want to call on so far plus 9, so 29, and then we want the last now to be 9 because that's the last value, right? And so that's what we'll pass here. So last is j, which is 9, and the length increased by 1, right? So now it's 29, and so we need to increase the length. Yeah, so we increase the length here, and yeah, that's pretty much it for this function. Now here what should we call? So for the first number 2, well, we should also try all numbers. Try to start with all numbers because except 0, of course, because we don't want leading zeros, right? And so to do that, we can just do for I in range of 1 to 9, and so to get to 9 we do 10. And then we start our helper function with this, and you might argue that we don't need actually to do this so far equal to 0, different than 0, because we already start only from 1. Yeah, I think that's valid, so let's remove it. Let's remove that, and then here what should be the last value? That's I, and what should be the length? That's 1. And that's pretty much it here, so let's run this. And let's submit. Cool, so that passes test cases. Yeah, for the leading 0, we can just start our loop here from 1 so that the first number is never 0, right? And yeah, that's pretty much it for this problem. Just explore all the digits, and as long as we have the conditions valid, keep going, right? Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.